Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the channel Chandan Physics. In this video, we are going to discuss Lauren's half-set polarimeter. Let's begin. What is polarimeter? That is an instrument which is used for the measurement of angle of rotation of plane polarized light by optically active solution. So, when plane polarized light is passed through optically active solutions, then the emergent light we see from that of optically active solution just rotated to an angle, which is called the angle of rotation, and the substances those are responsible to produce such angle of rotations are called optically active substances. So, polarimeter is such kind of instrument. By using that polarimeter, that angle of rotation means when that light passed through that of optically active substance, it is rotated to an angle. That angle of rotation is measured by using polarimeter. If the polarimeter is used to determine the optical rotation of sugar solution, then it is called saccharimeter. If that polarimeter is used to determine the angle of rotation for the optically active substances sugar solution, then that type of polarimeter is called saccharimeter. Next, come to the construction part of polarimeter. First, I figured out the constructions, then explain. Monochromatic source of light, yes, and a convex lens is used. That is why here we see unpolarized light arrowhead represent the vibrations along parallel to that of plane of the paper, and dot represent the vibrations perpendicular to that of plane of paper, which is passed through that of nickel prism. Nickel prism N1, which acted as an analyzer. So, that nickel prism acted as double refracted crystal. So, it is split up into two rays, one is E ray, another one is O ray, and that O ray is reflected back as Canada balsam is used, and only E ray passed through that of nickel prism. Here we obtain plane polarized light, plane polarized light, and use a glass tube here through which the optically active substances are used. This is the glass tube. In that of glass tube, we use optically active substances. So that the plane polarized light now tilted to an angle, that angle is called angle of rotation. Another nickel prism is used. That nickel prism as an polarizer. This one is a polarizer, as it produces plane polarized light. That nickel prism as an analyzer, which analyze what kind of light it will be, either polarized or not. And N1 and N2 are crossed with each other. After that, a telescope is used. This is telescope. To observe that light, and there we see it in our eye. In between the glass tube and polarizer of that of plane polarized light, use a plate which is called half shaded plate. Half shaded plate. What is the function of half shaded plate and why we use that half shaded plate in between this, that can be discussed later on that video. This is the unpolarized light. Unpolarized light, convex lens, the source, monochromatic source, source of light. In that of construction part, it consists of glass tube G, in which the solution whose optical activity is to be measured is kept. Glass tube G, optically active substance is placed here. The glass tube is placed between two crossed nickel prisms N1 and N2, which act as polarizer and analyzer respectively. That glass tube is placed in between two nickel prisms N1 and N2, whereas N1 acted as polarizer and N2 acted as an analyzer. In that figure, S as monochromatic source of light, which is placed at the focus of convex lens L, such that the parallel beam of light is produced. Source, which is monochromatic source of light, using a convex lens in such way, means at that of focus, therefore the emergent lights are parallel. This parallel beam is incident on nickel prism N1, which produces plane polarized light, as we say N1 acts as an analyzer, which is then passed through the half set plate S and glass tube G containing the solution. That unpolarized light passes through that of nickel prism N1 that acts as an analyzer. After that we see plane polarized light, and that plane polarized light now pass to half setted plate and again through that of a glass tube where optically active substances are present, which is then passed through half setted plate S and glass tube G containing the solution. Then the emergent light from the solution falls on the analyzer, that is nickel prism N2. Finally, the emergent light is viewed through that of telescope T. The nickel prism N2 can be rotated about the direction of propagation of light as the axis, and the rotation can be measured with the help of a circular scale. After that plane polarized light, it is rotated at an angle, and that plane polarized light passed through that of nickel prism N2, which acted as an analyzer. By using that of nickel prism N2, we can analyze what be that nature of that plane polarized light, or again that plane polarized light, rotated plane polarized light passed and observed through that of telescope. In between this, we use a scale, that is the circular scale. Circular scale means what be the angle of rotation of that plane polarized light can be measured by using that circular scale. First, we crossed that polarizer and analyzer. So, we see no light is passed after that. It can be understood in that of working section. Let us come to that of working. The aim of that polarimeter to calculate the angle of rotation. So, to calculate the specific rotation of an optically active substance, we use the relation as the specific rotation is equal to theta divided by L into C, whereas theta is the specific rotation, S is the specific rotation, theta is the angle of rotation, L is the length of that tube through which optically active substance is placed, which is the length of that of tube, and C is the concentration of such optically active solution that is placed in that of glass tube G. Here the value of L and C are known to us, but only the angle of rotation can be find out by using that Lauren's half set polarimeter. We have to calculate the angle of rotation. How to calculate that angle of rotation? As you know, when plane polarized light is passed through that optically active substance, then it is rotated to an angle called angle of rotation. See that construction, when plane unpolarized light passes through that of nickel prism N1, then it is polarized. So, when polarized light is passed through that of optically active substance, then it is rotated to an angle which is called the angle of rotation. Therefore, that angle of rotation theta can be easily find out by taking the analyzer N2 in such a way that no light or zero intensity is observed, and that angle of rotation is noted by using circular scale. At which angle that is rotated, that can be measured by using an analyzer. We set that analyzer to that of polarizer in the crossed way, means there will be no such light passed. Then the angle of rotation is measured, and that measurement we obtained from that of circular scale. but it's difficult to point out what be the exact point at which we observe no light or zero intensity. That is the angle of rotation, and that is measured by using that of circular scale. But what be the angle of rotation means it can be understood by taking the minimum intensity or zero light after that of nickel prism N2, but in that particular situation it is not a fixed point, means there will be a variable range point through which we obtained minimum intensity or no light. That is why it is difficult to point out what be the exact point at which we obtain zero intensity or no light. But it is difficult to point out what be the exact point at which we observe no light or zero intensity. That is why we introduce Laurent's half shade plate to overcome such difficulties. Means by using that Laurent's half shade plate, we can easily point out what be the exact point at which we can observe zero intensity or no light. So we introduce half shaded plate, Laurent's half shaded plate in between the polarizer and the glass tube. What is the function of that Laurent's half shaded plate? Its construction and function. It consists of two semicircular plates. One is made up of quartz and another with glass. Two semicircular plates like this. One part is made by quartz, another part made by glass, and these two are cemented. Both the plates are cemented. The thickness of quartz plate is such that it produces a phase difference of pi or a path difference of lambda by 2 between O ray and E ray. That quartz is a uniaxial positive crystal and it is a double refracting crystal. So when light passes through that of quartz, so it is splitted off into two such ray, one is O ray and another one is E ray. But here we choose the thickness of that of quartz in such a way that there is a phase difference of pi, or we can say that is a path difference of lambda by 2 between O ray and E ray. That is why that the quartz plate is called half wave plate, since it produces a path difference of lambda by 2 between E ray and O ray. So here that quartz plate is acted just like a half wave plate. So it is a half wave plate. And again the thickness of that of glass plate is such that it transmits the same amount of light as through that of quartz plate. But with the amount of light transmitted from that of quartz plate, again that amount of light is transmitted through that of glass plate. So the thickness is chosen just like this way. So how we use that of Laurent's half shade plate? As we say here, this is x o x dash, that is y o y dash. When that plane polarized light is incident, plane polarized light is incident OP. So it is splitted off into two rays, one is E ray, another one is O ray. Here is the E ray, another one is the O ray. In case of quartz crystal, it is a positive crystal, so the velocity of O ray is faster than that of velocity of E ray, and there will be a phase difference of pi. So E ray moves faster, so the direction of O ray just like this, and there will be a phase difference of what? Pi. Now E ray and O ray, the resultant will be this one, OQ. Therefore, the light is now equally distributed on that of quartz plate as well as glass plate. In this way, by adjusting that analyzer, means if the optic axis of that of analyzer is parallel to that of optic axis of such Lorentz half shade plate, then we see one plate is shaded and another one is brighter. On that basis, by arranging these two, we can easily point out what be the point at which we see minimum intensity or zero intensity. So therefore, by adjusting N2 and that half shaded plate, we can easily point out the zero intensity or no light point to calculate theta. Okay. So for that reason, Lorentz half shaded plate is used to overcome such difficulties as we faced here. So here with the help of this video lecture, we understand the concept of Lorentz half shade polarimeter. What is polarimeter? If we use sugar solution, then it is called saccharimeter, and the construction of Lorentz half shaded polarimeter, then working, and finally why Lorentz half shaded plate is used here and its function as well as construction. So with this useful and informative notes, let me wind up the session. Thank you.